The common logarithm has to do with our current number system. We are on tens, 20s, 30s. You have 10 fingers, you have 10 toes. So, the common logarithm is base 10. We shorten it by omitting writing the 10 for the base. So if you ever see log x, or log and then a regular sized number, it's always base 10. So, for our examples, log of 10 is 1. Because it's really 10 to the y equals 10. So it must be 1. Log 100 is 2. Because 10 to what unknown power gives you 100. So 10 squared is 100. But what do you do if they aren't perfect? Like log 50. We don't know. 10 to what power gives you 50? It's not an integer. But 50 falls in between 10 and 100, so we know it's going to be greater than 1 and less than 2. There's a great button on your calculators called the log key, and you can put this in. Log only works for base 10. So you put in log 50, hit enter, and you get out 1.69897. So let's round it to 1.7. This is what the graph of log of x equals. So base 10, we are getting very close to our asymptote, the y-axis, and then we go through 1, 0, and we get bigger. So we have some properties of logarithms. Our first property is log base a 1 equals 0. Because when you put it into an exponent, a to the 0th, anything to the 0 power, is 1. Log base a equal 1. It's like they cancel each other out and go to 1. Because when you put them in an exponent, a to the first is a. Log of base a to the x equals x. When you switch it to an exponent, it goes to a to the x equals a to the x. This is written a little funky, so it's really a to the log base a x. It goes to x. This all cancels each other out, and you get x to equal x. So some examples. Log base 7, a 7 to the 8th. This is example, or property 3, so it just goes to 8. 4 to the log base 4 of 23. This all cancels each other out, and you get 23. Log base 85 of 85. Same numbers, it goes to 1. We also have the natural logarithm. Logarithm with base e denoted by ln for natural log. So it's ln x is really log base e x. The natural log is the inverse function of y equals e to the x. And here we see how to put it into an exponent. So we do have properties of natural logs. The ln of 1 equals 0, and we convert it back to an exponent using e, because e to the 0th is 1. Ln of e equals 1, because you are going to have e to the first equals, it should be an e right there, I'm sorry, e to the first. Ln of e to the x is x. When you convert it, it goes to e to the x equals e to the x. The last one's a little bit trickier to understand. You have e to the ln of x equals x. The e and the ln, e to the ln cancel each other out. They always cancel each other out. Ln and e cancel each other out, you get out x. Ln and e cancel each other out, you go to 1 because there's nothing else there. So e and ln's cancel each other out. Some examples is you have ln of e to the 3. It just goes to 3. The next one's a little bit more complicated because you have a fraction. This is really in better written terms. Ln of 1 over e to the 4th. We write it so there's no fraction. So it goes to ln of e to the negative 4. The ln and e's cancel each other out and you get negative 4. On the next one, it's the ln of 7. This is where you use your calculator, find the ln button, and compute it. Round it to 2 decimal places, let's say, and you get 1.95. So now we have ln, e to the ln of square root of 11. The e and ln cancel, and you get root 11. The last thing we're going to cover today is finding the domains of a function. All logarithmic functions, whether the common log, the natural log, or just logs any base, they're always defined when x is greater than 0. So whatever's in here, we got to make it greater than 0. So we have f of x equals the natural log of 9 minus x squared. So it's defined whenever x is greater than 0. So whenever 9 minus x squared is greater than 0. So we are going to change this around to get x squared alone. So x is defined when x squared is less than 9. Therefore, it's defined. And we want to say when the absolute value of x is less than 3. Because we're going to have two answers, negative 3 and positive 3. And we're going to express that in the next line. X is defined when negative 3 is less than x is less than 3. So we write it into interval notation from negative 3 to 3.